Just like all sedimentary deposits, we can tell a lot about the past history of environment by looking at the layers, by looking at those pages in the history book. Right. One of the best places to see this is at the Grand Canyon, right? Each layer in the Grand Canyon was formed in a different environment, and so it has a different color, a different mineralogy, a different texture, a different hardness, different vegetation, all that good stuff that tells us what the environment looked like when that deposit was formed. Now, the main sedimentary unit that produces each layer is what we call a bed, right? And a sedimentary bed is a layer that is distinguishable from layers above and below it because it has its own unique rock type, grain size, physical properties, things like that. So every single one of these names on this picture of the Grand Canyon is a bed, right? We've got a limestone bed and a sandstone bed and a shale bed and so on and so on. And because of the law of superposition that states that the oldest material is deposited first on the bottom and the younger material is deposited progressively on top of that, we can go to a place like the Grand Canyon, start from the bottom, read upwards going forward in time, and know exactly how this environment changed over time. And often we can look at the history of sea level rise and fall, which is preserved at the Grand Canyon as an example. So sedimentary rocks formed during a sea level rise and fall have a characteristic sequence, right? Deposits formed during the rise of sea level are said to be transgressive because the shoreline advances or transgresses onto the continent. So a transgressive sequence might start off as a sandstone preserved on the beach, and then as sea level rises, that sandstone is covered by a shale that's formed in shallow water, and the water continues to rise, and that could be covered with limestone that forms in slightly deeper water. Right, so that's a transgressive sequence: sandstone, shale, limestone. And then if the sea level then regresses or falls, we get the opposite, right? We start with really deep limestone, sea level falls, we get that shallow shale, sea level falls even more, exposing a beach, and we get that sandstone. So that would be a regressive sequence.